All right, today we're doing something a little different. We're going to put on our detective hats. We're going to stop thinking about selecting data as some boring chore and start treating it like a thrilling investigation. Seriously, by the end of this, you'll know how to find any clue, no matter how deep it's buried in your dataset. So let's open the case file.
So picture this. You've got a case file, and it's got 397 suspects. That's a lot. And somewhere, hidden in that massive pile of information, is the one clue you need to crack the entire case. So how do you find it? I mean, you can't just flip through every single page hoping you get lucky. You need a real strategy. And that's the whole point, isn't it? You don't scroll aimlessly through data. You investigate. You use powerful, precise tools to zero in on what you need. So forget manual searching. We're about to learn the forensic techniques of data analysis using the Pandas library. Our case file for this investigation is the academic salaries dataset. It's got 397 rows, which we'll call our suspects, and a bunch of columns with info like their rank, sex, and of course, salary. This is our crime scene, and every single data point is a potential clue. Okay, so what's a detective's first move? Well, you have to decide which pieces of evidence are even relevant to look at. In the world of Pandas, this just means selecting the right columns. Think of it like deciding which specific case files to pull from the archives. This slide right here breaks it down perfectly. When you select a single column, what you get back is something called a series. Just think of it as pulling one specific document, like a list of everyone's salary. But if you select multiple columns, you get a data frame, and that's like grabbing the entire case file with all the related documents inside. So, technically speaking, a series is just a one-dimensional labeled array. To get one, it's super simple. You just use single square brackets and the column's name, just like this, df/salary. That's it. It's clean, it's easy, and now you have your first piece of focused evidence. Now, here's a detail that trips up a lot of people at first, so it's really crucial. If you want to pull multiple files or multiple columns, you have to give Pandas a list of those column names. And how do you make a list in Python? With brackets. That's why you see double brackets here. The outer set tells Pandas, hey, I'm selecting something, and that inner set is actually creating the list of columns you want.
Okay, we've got our files. We know which evidence we want to look at. Now it's time to pull out the magnifying glass. Filtering is how we narrow down our 397 suspects based on very specific criteria. This is where the real detective work begins. Let's start with a really direct question for our investigation. We need to find every single professor in our dataset who earns more than $120,000 a year. This is a classic filtering problem. So how do we do it? It looks a little weird at first, but it's pure logic. You give Pandas a direct order inside the brackets. That inner part, DF, salary greater than 120,000, is basically a little test. It goes through every single row and asks, is this salary greater than 120,000? The result is a list of true or false answers. Then, the outer brackets take that list and only show us the rows where the answer was true. Pretty clever, right? And boom, just like that. With a single line of code, we've instantly cut our suspect list from 397 all the way down to 198. This is the incredible power of filtering. No scrolling, no checking things by hand, just an immediate, accurate result. But, real investigations are rarely that simple. You often need to combine multiple clues to get to the truth. For that, we use logical operators. The ampersand and, that's our and operator. It means both conditions have to be true. And the pipe, pi, that's our or operator, meaning either one of the conditions can be true. Let's see how this works with a tougher case. Say we need to find all the female professors. We can break it down logically, just like a detective. First, we create a condition to identify all the suspects where the gender is female. Second, we create another condition to find all the suspects where the rank is prof. Then we just use that and operator to find the overlap, the suspects who satisfy both conditions. It's just pure logical deduction. Okay, it's time to bring out the high-tech forensic tools, .loc and .iloc. When you need to pull a very specific piece of evidence, a particular suspect, or just one detail about them, these are the go-to instruments you'll want to use. This right here is such a brilliant way to understand the core difference. .loc works with labels, the actual names of your rows and columns. Think of it as finding someone by their name tag. .iloc, on the other hand, works with integer positions, the numerical order of your rows and columns. That's like identifying someone by their number in a police lineup.
And this table just makes it even clearer. If you want to find Professor Smith by his name, you use .look. But if you just want to find the fifth person in the line and you don't care what their name is, you use .iloc. One uses names, the other uses numbers. Simple as that. So let's see it in action. If you want to grab the very first suspect in our list, you just use df.iloc0. Since .iloc is based on position and counting in Python starts at 0, this instantly gives you the entire first row of our data.
And what's so cool is that it works just like a Python list. If you want the very last suspect, you don't even need to know that there are 397 rows. You can just use df.iloc-1. It's so flexible and intuitive. You can also grab a whole lineup of suspects at once. Let's say you need to examine suspects number 10 through 19. Well, you can just slice them out with df.iloc1020. This lets you pull a whole chunk of your data based on its position in the file.
And this is where it gets really powerful. You can combine row and column selection. This command using .loc is basically saying, hey, give me the suspects from index label 10 to 20, but I only want to see their rank, sex, and salary columns. This is what precision data extraction is all about. You know, every good detective knows the rules and avoids the common pitfalls that can mess up a case. In data analysis, one small mistake can send you down a completely wrong path. So let's quickly cover a few key rules of thumb to keep our investigations clean and accurate. Okay, here are the crucial rules. First, whenever you combine filters with and or, you must wrap each condition in its own set of parentheses. That's not a suggestion, it's a hard rule in Pandas. Second, always try to use .loc or .iloc for selection. Chaining brackets together like df_salary0 can sometimes give you weird warnings because Pandas gets confused about whether you're just viewing the data or trying to change it. So stick to .loc and .iloc for clean, reliable code.
And this quote really sums the whole thing up, doesn't it? What we've covered today isn't just a random set of commands. It is the absolute foundation of all data analysis. Once you master these skills, you stop wasting all your time looking for the data, and you can start spending your time actually understanding what it all means.
So there you have it. You now have the essential tools of a data detective. You can select your evidence, you can use your magnifying glass to filter suspects, and you can use precision forensics to extract the exact clue you need. The only question left is, what case are you going to crack open first?